Hello everyone, my name is Chris Kim, and in this video we're talking about the application class provided by the Beaker framework. To create an Algorand smart contract using Beaker, you instantiate the application class. The application class contains all of the basic functionalities that an Algorand smart contract needs. Think of it like a bare-bone template for Beaker smart contracts. On Algorand, we call smart contracts applications, so I'll use both terms interchangeably. To create an application with Beaker, you can do so by instantiating the application class like this. And just like that, you create an application named Hello Beaker on Algorand with Beaker. Now let's talk about some of the methods included in the application class. First, the apply method. With the apply method, you can apply some blueprint functions to the application when creating the app. Let's look at some examples. Here we're creating an app called Simple App, and is taking in an instance of a class called AppState as a second argument. We'll cover states on Beaker smart contracts in a later video, so don't worry about it too much here. But basically, by including the instance of the AppState class in here as a second argument, the application that is being created here will have access to all of the states that are defined in the AppState class. Then we're calling the apply method with unconditional create approval as the first argument and the initialize global state set to true as the second argument. This is saying, hey application class, when you're creating this simple app, initialize the global states defined inside the AppState class to their default state. Let's look at another example. Here, now we're applying the unconditional opt-in approval method. This code is saying, hey application class, when someone opts into the smart contract, automatically initialize their local state defined in the AppState class. For those who don't know the difference between global and local state is state recorded on the application, while local state is state recorded on individual accounts. Hence the reason why the code is initializing local state when an account opts into the smart contract. Now the apply method is syntactic sugar for calling a blueprint method on an application instance and applying the method fluently at the same time you create the application instance. So you don't have to use the apply method to initialize these states. You can implement the initialization of states with methods inside the smart contract you create. Alright, now moving on to the build method. The build method takes our smart contract written in Beaker and PyTeal and transpile it to Teal source code, where Teal is a low-level assembly smart contract language on Algorand that the AVM understands and executes. The build method returns an instance of an application specification class, which includes the export method. This export method will write out 4 files into your file system. 2 of those files are approval.teal and clear.teal files, which include Teal source code of your Beaker smart contract. The other 2 files are contract.json and application.json files, which are ABI specifications of your smart contract. ABI is a shorthand for Application Binary Interface, and is an instruction for the front end or other smart contracts on how to interact with this application. So by doing app.build.export to artifacts, this will write out the 4 files I mentioned into the artifacts folder. We'll see what this looks like in the code demo. The application class also includes decorators that mark methods to handle different types of application calls. When sending an application call to the Algorand smart contract, you need to specify what action this app call is taking. Otherwise, the application won't know what part of the smart contract to execute. If it's just a normal call to an external method in the app, you specify the app call as a no-op application call. Then the smart contract will know what external method to execute. If you're sending a transaction to opt into the smart contract, you specify the app call as an opt-in application call. In an opt-in application call, we'll call the method decorated with the opt-in decorator. I'll be going over these decorators more in detail in the decorators video, so don't worry if you don't quite understand what these are yet. Now let's look at a code demo to see the application class in action. Alright, I'm inside the application class, and again, if you want to follow along and run this code on your machine, head over to the description where you can find the link to this GitHub repo. Alright, let's look at the contract.py file. Like always, we're importing in Beaker and PyTeal, and let's first take a look at line 12, where we are instantiating the application class provided by Beaker. And for the first argument, we're putting in the string simple app, and that will be the name of this application. And the second argument, we're putting in the instance of the myState class, which is defined over here. Like I said, I'll be covering states in a later video, so don't worry about it too much here, but inside the MyState class, we have a global state defined called appState, and the default value is number 10. So by putting the instance of the MyState class as a second argument into the application class, this app now has access to all of the states inside of this MyState class. All right, we're going to apply a blueprint function called unconditional create approval. And we're going to set initialize global state to true. So what this code is doing is when this simple app gets deployed onto the network, it's going to automatically apply this unconditional create approval method, and it's going to initialize the global state during creation, which means this app state global state is going to be initialized and set to the int value of 10. Now, this smart contract has one method called read state, and all it does is it's going to read this app state once it's called. Now, this app.external decorator here is also something that comes with the application class. And what it's doing is it's registering the read state method into this app instance. Again, there will be a separate video on decorators. All right, now let's head over to deploy.py and see how we can deploy and call this smart contract. Here, we're importing in the app that we defined in the contract.py file, and we're going to take that instance and call the build method defined inside of the application class and export the artifacts into the artifacts folder. Then we're going to use the sandbox and client module from Beaker to get some test accounts from the local environment. And we're going to get one of those accounts and set it as sender. And we're going to create an app client here. And we're going to use that client to create the app and call the read state method and print out that return value. So let's head over to our terminal and see what this looks like. I'm going to run python 3 deploy.py. And you can see that the return value returned 10, which is the default value that was initialized during creation. Now let's deploy and call this smart contract using Datflow. Datflow is an Algorand developer toolkit web app that you can use to easily deploy and test out your contract. To do that, you want to type in algokit explore, and this will automatically launch Datflow in your browser. Now, if you watched the Master PyTeal series, you should know how Datflow works by now. But if this is your first time, what you want to do is you want to head over to Dev Wallets and create a test wallet that you can play around with. It's going to automatically dispense 100 test algos for you to play around with. And if you need more, you can just click this dispense button and it will dispense 100 algos for you. Now head over to Beaker Studio and let's import in the ABI specification of our simple app so that Datflow knows how to deploy it and call it. So click select app, import Beaker app, click file, upload file, find the project folder, go into the artifacts folder, and then import in the application.json file. Now, because the application.json file has all of the information about the smart contract, Datflow was able to retrieve everything that it needs to know to deploy and call the smart contract by just importing in the application.json file. So you can see the global state app state here, the teal source code for approval and clear programs, and the method read state in the application binary interface section. Now to deploy this, click create app and click create, and that will deploy this application to the local network. All right, now let's see if our apply method worked properly. Now, when we call this read state method, it should return 10 as a default value. Click read state, click execute, and then click execute again, and you can see the returned value is 10 as expected. So if you prefer to use a web interface when you're testing your code, Datflow is what you want to use. Today we learned what the application class is and what methods the class has. We also did a quick demo of using the application class to create a simple smart contract, initialize local and global state, and build the artifacts of the smart contract to create and call external methods defined in the app. We also used Datflow to deploy and call our smart contract with the web interface. That's it for today. Let's move on to the next video.